we're told to solve. What we want to find out is what works for y. Now, once again, just like our last problem, if it's not equal to 0, the very first thing I need to do is get it equal to 0. We only have a product property of 0. Well, now we're tasked to factor it. We need to make the product before we can use our product property. The problem is there's no GCF and we have that leading coefficient. Time for the AC method, our divide and conquer, that factor by grouping that we're going to need to do. 12 times 2, right? A times C gives me 24. Let's go ahead and make ourselves a table. 1 times itself, 2 times 12, where it came from, 3 times 8, 4 times 6, 5 won't go into it, 6 is repeating. Since I have a negative 2, I'm going to subtract these. 24 minus 1 is 23. 12 minus 2 is 10. 8 minus 3 is 5. 6 minus 4 is 2. 5 is the number we were looking for. 3 and 8. Going through the whole technique. First term stays the same. Constant stays the same. FOIL backwards. We're splitting up that middle term. Where I'm going to use that 3 and 8. Notice I'm going to have and you can put them in whatever order you want. Negative 8x plus 3x combined to be my negative 5x. Sign of the bigger number gives me that negative. Using that 3 and 8, let's do our factor by grouping. Divide and conquer. In the first two terms, my GCF, oops, sorry, those should have been y's. GCF, 4y. Leaving me 3y minus 2. If we distribute, 4y times 3y is 12y squared. 4y times negative 2 is negative 8y. GCF on the other side, when there's no GCF, it's always that 1, right? Nothing's in common with 3 and 2, and there are no common variables. 1 times 3y minus 2. And you notice when I distribute, I get the same thing. But notice that was because of my common binomial, 3y minus 2, 3y minus 2. Factor it out, leaving me 4y plus 1 equal to 0. Now, we have our product of binomials. Set each binomial equal to 0. It won't be as simple as just plain changing the signs. We have coefficients now. Remember, what caused us to do this lengthier method was having that 12 in front without a GCF. Well, notice now what that's going to do is that's where the 3 and the 4 ultimately came from. Do my inverse operations. Add 2 to each side. 3y equals 2. Divide by 3 to each side. Y equals 2/3. Minus 1 to each side. 4y equals negative 1. Divide by 4 to each side. Y equals negative 1/4. Here are my two solutions. Remember, what caused us to have fractions? We're having the coefficients. What caused us to have coefficients was having that 12 in front. That 12 caused a lot of headaches. We needed the AC method, the divide and conquer, and it left us with fractions. A lot more work, but nothing different from what we even did on the last problem. It just happens to be more extensive and more steps along the way, and then more confusing when we look at them. We don't like to deal with fractions, but it is the same as what we had. It is the same as when I go back to my original equation, right? What I started with, remember that these are my solutions. If I go in and I plug in 2/3, and this is going to be a lot of work to try solving this, but very possible. Squaring a fraction. Power of a quotient means square the top, square the bottom. To multiply times 12, I need to put the 12 over 1, multiply top and bottom, reduce. When I multiply times 5, put the 5 over 1, top and top, bottom, bottom, reduce. What I need to do is get a common denominator. With a common denominator, I could add the numerators, divide. Long story short, what I would get is 2. That 2/3 is what works in that equation. And it would be the same as if I put in negative 1/4 and squared it and multiplied it and combined it and multiplied it. That's what I would end up with is 2 in both cases. These are my two answers. In Math Excel, separate your answers with a comma. I'm looking for what works.